Hello, this is a video that's going to go over parallel and perpendicular lines. This was a lesson that we completed. It's the last lesson of this unit. So I'm going to go over just kind of what a parallel, perpendicular lines look like, as well as how to determine whether or not the lines are parallel or perpendicular. So parallel lines have the same slope, but different y-intercept. Remember, parallel lines are lines that don't touch. So if I, oopsie, that's not the right one. If I look here, there we go. I'm looking at lines that are parallel. That means that if I were to graph them, the lines look the same. So let's just do like 3x minus 1. So their steepness is going to be the same, but where they cross the y-axis is not. So those lines will be parallel, and kind of that's the pattern, regardless of whether or not, let's change it to maybe like -1/3, oops, and then we'll do -1/3. So the y-intercepts are going to be different, but the slopes will always be exactly the same because they never intersect. So some examples of that would be like the same one we just did, like y equals 3x plus 1 and y equals 3x minus 3. Or y equals 1/2 x plus 2, or y equals -1/2 x. It can also be vertical lines, like x equals 2 and x equals -1. You can graph those as well. X equals 2, remember it looks like a vertical line, and then x equals -1 will look like that. So those lines are also parallel, and y equals 2 and y equals 1, whether your slopes are 0. So all of those are parallel lines. Perpendicular lines have opposite and reciprocal slopes. And the b is not important. So normally the b is not the same, but it can be the same if they intersect on the y-axis, if that's where the points or the two lines cross over. So think about it this way. If you're looking at a graph and you want to take this line that you were going maybe up 2 over 1, I was trying to make it so that I had a line that was going directly at a 90-degree angle, which is what perpendicular is. I would want to go down 1, oopsie, and to the right 2, down 1 and to the right 2. And that way you get a nice line where it's going to intersect at a 90-degree angle. So some examples of that would be like y equals, let's say 3x plus 1, and y equals -1/3 x plus 5. Those lines have the opposite and reciprocal slopes. So if one's positive, the other one has to be negative. Or if one's negative, like in this case, and think about how you would move on the graph, I would go down 2 to the right 3, down 2 to the right 3. We want to move on the new graph up 3 and to the right 2. Up 3 and to the right 2. So again, the y-intercepts don't matter. They can be different depending. Okay, so we did a little card sort, which I'm not going to put on this video, where we were comparing lines that were parallel perpendicular. So the second kind of part of this, after being able to identify whether or not it's parallel, is writing the slope of a line that, the new line that passes through y equals mx plus b, and use the point to find b. So for example, we're looking for a line that's parallel to this line, but instead it goes through the point 2, 3. So it's not going to be the same line. But we know that the parallel lines have the same slope. So I'm going to do my new line is y equals 3x plus or minus something. To figure out what exactly that is, we're going to substitute in x and y into our equation. So we get 3 equals 3 times 2 plus b. 3 equals 6 plus b. We're going to subtract 6 from both sides, and then we get -3 equals b. So your entire equation would then be y equals 3x minus 3. Now for the next one, we're going to do the same kind of thing. In class, we practice it, so if you want to hit pause and then just fast forward on top of me doing this problem, that would probably be a good idea if you're following along because you weren't here or something on class or you need an additional practice. So for this one, we're going to start with the same slope, so 1/2 x plus b, and we're going to substitute in the 2 for x and the 3 for y. So we get 3 equals 1 plus b. So my y-intercept is going to be 2. So your whole new equation would be 1/2 x plus 2. Now you can check this on Desmos. Let me swing it back over. So the original line, let's say for the second one, was y equals 1/2 x, and then it was minus 3. The line that I got when I wanted a line that was parallel but goes through the point that they gave us was 1/2 x plus 2. Okay, so looking at it, you can tell right away, boom, those are definitely parallel lines. The second part was the ordered pair. It went through 2, 3, right, that part there. So I can go ahead and type in the ordered pair, 2, 3, and it should go through that purple line. It should go through the new line. So 2, 3, and there it is, going right through the purple line. So it's a really great check for that. Okay, so that was kind of the first part of the second section of this lesson. The second part is if the lines are perpendicular. So for this part, we're going to do, they're giving us a line here, and we want it perpendicular, so not same slope, right? And it's also got to go through this point here. So if lines are perpendicular, now we're going to be at 1/2 x plus b. We have to do the opposite, which means negative to positive. Now it's also going from 2 to the reciprocal, which is 1/2. And then we're going to do the same second part. So we're going to plug in -5 for y, and then 4 for x. -5 equals 2 plus b, and then we get -7. So your whole equation for your line would be 1/2 x minus 7. Yep. And for the second part, so if you want to practice this again in your notebook, and then go ahead and copy it down or fast forward through the video, that'd be a good idea too. So if we're looking at the line perpendicular to this line, so it's not going to be the same slope, we're going to do the opposite reciprocal, so it's going to be -4x plus something, and then we're going to use our ordered pair to find b. So it'll be 4 equals -32 plus b, and it looks like it's going to be 36 when I add 32 to both sides. So the whole equation is going to be -4x plus 36 for that one. Okay, thanks for watching. Hope it was helpful.